Welcome back to this video lecture series on data structure and algorithms. Today we'll be starting with queue introduction and application. So what is queue data structure? We have already seen that queue is one of the linear data structures. This particular data structure follows again a particular order in which the operations in terms of addition and removal of elements are performed. This particular order is termed as FIFO, that is first in, first out. It simply means that the element that gets entry first in the queue, it gets out of the queue at the first. One point that is to be noted, or which can be considered as a difference between queue and stack data structure, is that in stack we only used one end to operate all the operations there. But in case of queue, insertion and deletion take place from different ends. As you can see in this diagram, these two different ends are pointed here. This one end is called front, another one is called rear. And we do the NQ and DQ operations from these two ends. We will be knowing about these in this later slides. Next comes the terms and operations we have to consider when we talk about queue data structure. So the very first terms are front and rear. As I have already mentioned, front is that end of the queue from which the removal of elements gets executed, and this is called front of the queue. And rear is that end of the queue from where elements get entry into the queue, and this is called rear of the queue. So as we had dealt with top of the stack, here we will be dealing with front of the queue and rear of the queue. Two ends for a queue. Next comes this function called NQ and DQ. These are almost same as push and pop. In stack we have seen that push. Here for queue it is called NQ. This operation is nothing but adding an element into the queue from the rear end. And DQ operation is nothing but removal of an element from the queue from the front end. Now there are some points that we should remember when we are dealing with queue data structure. First thing is that once a new element is inserted into the queue, all the elements inserted before the new element in the queue must be removed to remove the new element. That is, all the elements that will be before that new element in the queue. In order to remove the new element, we have to get rid of all those elements which were before the new element. Only then it can be removed. So like in this diagram, suppose the new element is inserted from this rear end and there are elements here. So until these all elements get deleted from this front side and that new element reaches here, only then we can delete it. Next point is that we have to consider the overflow and underflow situations here. So queue of overflow results from trying to add an element onto a full queue, and underflow happens when we try to remove an element from an empty queue. Lastly, we will be seeing some of the application of this queue data structure. So the first point is that the first in first out property is useful in scenario like when a resource is shared among multiple consumers, so that we can maintain a proper order in order to serve the consumers. Next comes when we talk about real life scenarios, we can take the example of the call center phone systems. What they do is they use queue to hold people calling them in an order until a service representative is free. That is how they can serve all the customers. And lastly, we can see that handling of interrupts can also be done in real life systems using the queue data structure. Thank you for watching this video and staying with us. See you next time.